So this is how we have a wireless OP900 and how it connects to this module, which connects to my weight pad. And you can see nothing connected. And I'm able to stand on it and get my weight. So this is going to be used on a 4x4 floor scale. So this is how you assemble and make an OP900 wireless. If you're interested, you can email the link in the description. So this is assembling the OP900 wireless. And on my left, you see this is the board for the OP900, and this is the regular board. So you see the layout's a little bit different. You'll see there's no actual connector for the load cell. Here it's missing, it's block. Because it's wireless, it's going to be transmitting and receiving wirelessly. So it's actually going to receive from the chip right here, this corner here, which doesn't have on the regular board. So you specifically need a board that has the wireless functionality, because we're adding the chip to it. So we're actually using the XB protocol, DG XB. So this is actually the chip we're going to be using. So we're going to put the chip into this board here. And you see it's labeled ground, 5V, D out, D in. So these actually have pins. And you see the layouts, make sure it's this direction. You put it backwards, it wouldn't work. Okay. So the wiring, it's going to match the wiring here. So we're actually going to use some header pins and solder them onto the board, solder some onto here, and then just connect them with these wires. Or you can just make your own wire and solder to the point, but you need specifically a board for the OP900. So this one will receive it, and I know it's going to seem like a lot, but this is a module we're going to connect to our platform that's going to be transmitting the signal. So I'm going to have the battery, the power switch here, the USB to charge here. So that's just like the casing of it. What's inside of it is these two boards. So this one specifically, you can see it uses the XB protocol, same as our chip that we have. So they're able to communicate from the board, from the housing from the platform, over the XB protocol. So this housing here will actually have connected to the platform itself, in this case, a floor scale. And we'll use this board inside, and over the XP protocol sent to this XP board, which then receives it to the readout here. So this particularly is a system on a chip. It has the XP protocol and the Arduino chip built in, so it's two chips in one. So it saves space putting inside here. And this other board is what actually receives the signal. You'll see it says the green, white, black, red cables from the platform. And these just to connect with the QWIC protocol, which is just this cable, plug it together, and right, so this will connect to the load cell, send it to this board, which transmitted over wirelessly to this DG XP chip on the board itself. And then you are able to get a wireless signal of whatever the platform has on it. So first, I'll start off with just the indicator. And then after this, you will actually program it to make sure to communicate with each other, the two XP chips. So now we're actually going to be adding the header pins here and here. So here's the board, and we're going to specifically work on this left side. And the top three pins. The top one is the 5V, the power that the board itself is receiving from the board. The second pin is the ground. And the third pin is the receive. So let's line up with this one, where you see ground on the top one, the 5V on the second hole, and D out. So it's outputting the signal to the board. It's transmitting right to, and it's receiving on the third hole. It makes it a little bit easier if you have the header pins. I would cut them, but if you had the header pins, you could switch them around easily. if you actually hardwired in, it's gonna be a lot. You can't easily remove and unplug the wires, so I use header pins. But just put the header pins for now, and same for this one. We're gonna put it on the ground, 5-volt, and D out. So solder that now. Okay, so I put the header pins on both ends. So I'm just gonna use wiring red for the 5-volt, green for like the transmit, receive, and black for ground. So remember the order. So the first pin on the board is the 5-volt. So that's the first one. It doesn't matter what color you use, just so you know which one is which. The first one, 5-volt. The second one is the ground. So that's ground. And then the transmit receive is the third pin. So make sure you have those. And then on here, it's labeled a little bit harder to see, but ground, 5-volt, D out. So, right, 5-volt is the middle one on the board. The ground, which is my black cable, is the first pin on top. And the D out, this is transmitting, so it's going to be the green cable. Just go to pin 3. Okay, so now I have those 3. So now the board is finished. I'm actually going to be putting this in the stainless steel housing here. But now I'll work on a little bit more challenging part, the actual housing itself. And this connects to the platform itself. So you have to know is you have to have a battery, red and black. We wire into the switch with the wiring for this board. All powering, because the power comes from the switch, or from the battery, but it goes to the switch. Make sure you turn it on and off. So what I usually do, housing here, I actually cut the battery terminals. And I'll strip the wire and actually connect it to the switch. So in this case, I'm actually gonna move the casing, switch. I orient it this way. We switch it upward. You'll see why. Put this nut around it. I keep same orientation so you know which one's ground, which is power. So the wiring for this is going to be plus, these are 2 plus ends, and this is the ground. So I take my first lead of the battery, strip the wire, put it inside this hole. Right, these 2 are for ground, so it's going to go ground. And then the board itself, it's wiring. It's going to go to the middle section for power, and the ground, common ground with this one. Sounds confusing at first, but one at a time. So I'll first show the battery, strip the wire, and then solder on the wire to switch. You see I have positive and negative. You would actually notice lights up. See, light goes on and off. So it gets power from the battery. The middle section is actually going to be for the board itself. I disconnected the other board, but so what's important is on the board itself, you can see VBAT is where your power, your positive end goes in, and your ground is right here. So you actually need to cut 2 wires. Strip the wire. And we're actually gonna see on VBAT, I'm using the red cable for that. It's gonna go to the center of the switch to get positive power, and then ground will go same as this one. So I got the board VBAT to the middle switch, and then the ground So the battery's still here. Just make sure you tug on each cable. Make sure the solder's good so it doesn't break off. So these two might be the most difficult work because there's two of them going to here. Sometimes solder it from both sides, make sure it's correct. But you'll know it's working because flip the switch. The switch light turns on. And there's little lights here. So you can turn it off. An advantage of using that protocol is that once it turns off, I can plug this in. It will get power and transmit data from this board to this board and over to the XB protocol to the PCB on the indicator over there. So when I flip the switch, you see it's receiving power here. The board itself receiving power right here. Right, the switch receive power, all from this battery. Just one last thing not to forget. See, this is the board. We actually need to short the 3v3 and the AVD. So your goal is actually to create this. See a little wire. It jumps 3v3 and AVD0. So I need to create this wire as well. So don't forget this because it will not work properly without it. I have it here. I actually added the jumper pin cable from 3v3. I'm guessing it's AVDD. See the second pin to the last pin. Make sure you add it because it will still light up, but it will not transmit properly if you don't have jumped those two pins. So when you turn on the switch, you see power light here, power light there, all coming from the power from the battery. So that's why this is the portion that will be connected to the platform itself. So we're actually going to put the battery in here. And we're actually going to have to... At least this part's finished. Turns off. For the housing, where the battery and the chip goes inside, we actually need to add the USB. So this will actually charge the battery itself. So you need a USB Type A to USB Type A. One end goes in there. And then you can just use a regular old wall plug to charge it. Nothing special. Just one we ship. 5 volt, 2.1 amp. Doesn't really matter. So when you attach this to here, one. On this end, in this particular case, we're connecting it to a 5-pin connector. So this is going to be to a 5-pin floor scale. If you connect it into a way pad, for example, if you want a wireless way pad, you add the way pad connector, the female end, to this one. This one is a floor scale, so we're keeping that 5-pin. But for sure, you're going to have to cut off these tabs because it won't actually go around it. It won't fit through. You won't be able to screw on the 5-pin connector on here, so I'll show you that now. But you might have to do the same for this one. So you can see I actually cut off on this end to make it smooth. And I'll show you what I used. Just cut here. Probably better ways of doing it, but doesn't matter how you do it. Just make sure it's flat here. So yeah, I already have my 5-pin connector. So this one specifically is going to use a 5-pin to connect with the scale. I cut it a little bit short already. But you take this off, feed it through. And there's not too much space here. That's actually why you have to cut it, because it won't make good connection. Put this on here. Right, because these wires, red, green, white, black, with the 5-pin, connect to the red, green, white, black in here. So, similar. This end's gonna go here. Should remove this part and move the cap. Should be there. So you see how it looks now. Make sure that's tight. Make sure that's tight. You see there's not too much space here. And so I'll input the switch this way. And now I could actually start placing the battery inside. And now put everything inside. Seems like a lot, but it's not too much. The only thing left is if I'm plugging it in, I can't power it at the same time. So what you're going to need is actually one of these two micro connector. The same one the board uses. Right, so this makes it where you can plug it in and use it at the same time. So this, don't forget this cable. Plug that in here. Okay, so that's there. This goes here. And if you have a standoff, you can use it for this one, where you connect two boards together so it's not moving around, just one piece. But I don't have one for now, but you see color coded green, white, black, red. So pulls down. See, make sure it's tight in there. See, it might seem like it's in there, but it's not. Make sure it's all the way in. Tug on it, make sure it's tight in there. Green, white, black, red. Red one, black one, white, green. So that's that. Careful the wires. And you can see how it slowly assembles together. Make sure the switch works. Make sure those two lights are on. If the light turns on for the big board, but the small board on top does not light on, make sure this connector is connected. And make sure if you like wiggle this cable, it doesn't lose power, because then it'll make unstable reading. So if it's all fine, and if it's not working, just replace the cable, but turn off and close it. And that's how you assemble the module on this. So after this, we're actually going to connect it to a computer and actually see, try to make sure to communicate with each other. So you see the XP board on the PCB for the OP900, and here's a module that connects to the platform. I already unplugged this cable, the micro USB cable. I am going to plug it into the computer, but it's easiest just plug it in directly to here instead of going to the USB here. So what I'm actually going to do is take the chip out on the PCB, and I use a different board because it's how else you're going to connect it to USB on the computer. So this is the board I use. Make sure same orientation. See the little marks here. This is what we use for programming, because then this has this connector. So that connector, you can plug it in, and now you can plug it into USB. And for the other end, it's same as the old Android charger. This connector to USB. So you plug it in here, and then plug both of them in to your desktop. So first, on your desktop, you can right click on the Windows button and the device manager, or here in search, type in device manager, because we can see what ports show up. I just want to make sure both of them show up first. So right now I don't have any ports, but if you did, you'll see something here. So I plug in the first one to USB. You see other devices, and you see CP2104, USB 2 ART. That's how I know it's that one, and we'll fix that later. And then connect the other one. And ports, right, COM9. And you can see it's saying something set up and ready to go, but it doesn't have a driver for it, so it still doesn't know what the device is. So in this case, if I untitle this, the problem is actually this board itself. This Windows computer does not have a driver for it. Most computers don't. So this one recognized fine. This is a problem. Because remember, this is a SoC, has an XP board, just like this one, and has the Arduino board in just in one piece. So for this one, you actually download a driver for it because you will be using a software called XCTU to communicate and flash the firmware on it. But you won't be able to flash firmware on this one because it will not be able to recognize it, and the software won't recognize it. So what actually you're going to do is open up your browser, and you're actually going to search for that specific driver. So you see CP2104, right? USB to UART bridge controller. Click on the Silicon Labs CP2104 USB to UART driver. And we're actually going to download. So I specifically have the Windows, this is Windows computer. But if you have the Mac OS version, you can download the Mac OS. So this is Windows 10. Okay, so I closed it, went back. Now you see it's downloaded. And I'm actually going to open my File Explorer. Let me open up a new one. Okay, I'm going to put this in its own folder. So put new, so you'll see what happens. Because you might lose where it went. And I move it over here. Open a new folder. Right click. And you can either use Windows built-in to extract the zip folder, or use 7-zip to extract here. So now you see all the files here. So in this particular example, I have an X64-bit. Yeah, for ARM and for other ones as well. But install. And you see it actually moved that unknown device. Now it's showing as Silicon Labs CP210X, right? All this. And the device updated. So that's good. Close. Right, have it here. So now you need to download XCTU because all the programming for the two chips can be done with this software. So open it up. And if you didn't do the previous step, you might not see one of the devices. And if you've done it once before and you installed it, you might have forgot. Just remember, if it's a new computer that doesn't have that driver, it will not recognize this board right here. Okay, so you're here. You can either add individually or you just scan all the ports that are available and with the question mark. And that's why it's important, because since it doesn't assign a COM port, it wouldn't recognize this device. That's why you specifically need that driver to assign a COM port to it, and then you could actually add it to the XCTU software to communicate with each other. Some other updates, just scan, leave all that default. Okay, so recognize my two devices. I'm going to add select devices. And I'll close that for now. You can see, you actually click on each one, seeing what it does. So this particular one, the XP, is this one. You'll know because it's the COM port assigned to it. And then this chip is the one over here. So I'm going to click on this one and actually see what's going on. So we're here. You can see I have the two chips here, one down there. So I have the document written up already. And that's why I specifically had to know which one you're working on. Is it the LC side, the load cell? That's the one that's plugged into the platform. In this case, it's this board in the case. And then the indicator side, IND side, is the XP board. So you need to know which side, because certain settings we need to change. More importantly, we have to have matching ID. So what we're actually gonna do first, okay, so this COM port 10 is the LC side. load cell, the casing, and then COM9, XP board, that goes to the indicator, so that's the indicator side. So there are specific settings you have to change. So first, what you want to do is actually update. So click on update, and we're using DG XP Zigbee 3.0, and you're going to select the newest firmware. You click update, and it doesn't use a different bootloader, so that's fine, because you see you can use different protocols. You can use Wi-Fi, you can use RF signal, you can use different technologies. So yes. Okay, so it's done updating. That took a while, but remember the update was the XB Zigbee 3.0. But you have other protocols you can use as well, and this is the newest firmware according to this time. And remember, this is the COM port 10, which in this situation is the module, this one, which uses the little long breadboard. So if you don't know which COM port it is, you can always right click, go back to device manager, and go under ports, and remember, I suspect it's the Silicon Labs CP. Just unplug it and you'll see it updating. No COM port 10, and I'll plug it in. Now it's back COM port 10. That's the one I just plugged in. So you know that one's COM port 10 because you need to know, because this is the load cell end. This is the one that connects to the platform itself. So that's the load cell. So remember ID, the first one. So this is just the ID. It will assign a channel according to it. What I saw before from someone before me was to use 3000 or more, because the frequency might interfere with something else. So you use whatever number you want here. I use 3321. Doesn't matter. CE, make sure that's 0, because you want to join a network. This situation is going to join the other XP board. Right, this one's CE0, CE1, but right now we're working on that one, the first load cell. So we did CE0. Next, make sure EE0 appears. So scroll down. Right, EE0. That's the default. But just make sure that's 0. And you go right by clicking that one. And that particular setting will be written to. Same thing with the C0. If it's not array 0, let's say it was 1 by accident, and then you can make that to 0 and write it immediately. Or you can just write at the end. Yeah, so it's a way of telling me what it was. But you could write it at the end, all the settings. You can see any with this blue arrow means I already changed it. It's already been changed, or by default it was changed. Well, it was changed from the default, let's say. The E0, so next will be AP4. So it's hard to find, but okay. AP4 for MicroPython. So specifically, we're going to use MicroPython, the software. That's actually what the rest of the document explains. So make sure it's 4, because this one, this module, the one connected to the load cell in this case, this little breadboard, will actually run the MicroPython code and actually distribute, send out whatever the signal of the weight to the XP board, the one connected to the load cell, of whatever the weight is on the scale. In this case, it's scale, but it could be whatever you want. So you need to make sure, and that's kind of the pain with MicroPython, where you can actually run the software on the computer, since there's no chip. It's a physical hardware. It's like an embedded system where you can only run MicroPython on a device itself that has a chip for it, which in this case this SoC does, but my computer or desktop can't run it. So I actually don't know if my software is working until it's actually run on the chip itself. So make sure AP equals 4, write that as this setting, and SM6 make sure MicroPython sleep. So you don't want to go in power saving mode where it conserves power, shuts it off, and then the scale's not working. So we want to make sure it's a 6 because it's going to continuously run the software. We're outputting the data with the current weight on the scale to the indicator, the readout institution. So make sure SM equal to 6. And you can see the next one will be D1 equal to 6. So scroll down. So it's using the I2C protocol, so make sure that's 6. Not using any other, so D1, 6. And last one will be the P1 equal to 6. And it's right here. So those are all the settings for the load cell side. Now we're actually going to work on the other end. Right, and you could click right to rewrite if you want, but I would click individually. So what's important, now you click on the next one. And we're going to do the exact same thing where we're actually going to update the firmware on it. And this specifically on the DG board to connect to the indicator. So now click on it, might take a while. And we're actually going to update to the newest bootloader firmware that they have. Okay, so you're here. You clicked on now the XP board connected to the indicator. You click on updates. And it's the same protocol. Make sure they're both matching protocol. So this specifically I'm using the Zigbee XP 3.0, the newest firmware 100D update. Might take some time, but same process. And it's going to say update different bootloader. That's fine. Okay, so it took some time, but finish updating. Okay, close this. Okay, so remember this is the indicator side. So it's what you updated. So remember the ID that was set on the previous module. I'll actually click on it to show you. I think I said 3321 or 3331, whatever it was. Make sure they match because the ID will assign a channel that's going to go on. And there's a certain amount of channels available, but I want to make sure that they match ID because if not, then it won't be able to communicate with each other. So this chip will not communicate with that chip. So you see 3321. So make sure that your chip also matches 3221. Okay, so back here, and we got the matched ID 3321, and I'm gonna write to it. It doesn't really matter what the ID is, it just matters that they match the two chips, so we're able to communicate on the same frequency. And we'll check that later on how to know that they're both running on the same frequency. So CE set to 1, because this is forum network. And the last one would be AP equal to 0. Yeah, AP 0, it's way at 0, so it's fine. How do you know what channel you're on? Is if you scroll down, and right now it says number of children 14. So this works as a mesh network where you have one chip at the center. This could be this one, for example, from the readouts, and you can have 14 modules, up to 14. That will send data to this chip and read. So in this example, one example, but it's only one channel. But we do have like the 6 pad that we have that takes 6 connections or 4 connections wirelessly and send it to just one chip. So 4 to 1 or 6 to 1 is up to 14. That's available on this chip. That's how many channels it has. I don't think the processing, it's actually the problem with DG board, it's actually the problem with this SoC here. This one has a problem handling more than 4. Even 4 is kind of unstable. It won't read correctly. There's too much data for the processor to handle. But anyways, and this says operating channel 0. So I don't think that's correct. If you scroll down, what has to happen is that both channels have to be the same. Channel is determined by the ID number. That's why it's so important. Yeah, it says operating channel 0. Okay. So I got it, the settings correct. Now it's about importing the MicroPython code into the load cell side. This is actually going to run the code and continuously send the output from the scale, in this case, to the DG board on the indicator readout. So what I actually need to do is go to Tools and MicroPython Terminal. And remember the COM port that you have, right? COM port, say 10. Open it, and you can press Enter. You see it's a terminal, and what you can do is Control F. Now saying you need to format first. If it's first time using this chip, capital Y formatting, and the actual software is in this document here. In this case, we're just going to copy this. And paste here. And we're going to press Control and D to actually save. And it's going to ask if you want to automatically run the code at startup. So once it notices getting power, automatically run software, which is yes. If it's powered on, you want to automatically send the data to the readout in this situation. So capital Y. And that should be it. And you can press Control R to rerun the software, like reboot itself, rerun whatever you're running. So you close this, and you go to this port over here to actually see the connection that we have. So if we open up this port, let's see if we can open up this port. Nothing currently, right? I open up both of the COM ports, I don't get a signal output. So you're on this board, what you need to do is actually press the reset button right here, it's underneath. You press it, and you see the flashing light up here. And you want to see the TX, RX being lit up here. So let's see, still rebooting. And sometimes it takes a couple tries where I have to reformat again, rerun the code, reformat, close, press the reset button. Okay, let me see if I unplug it from USB, replug it in. Okay, I don't know if you can see it, it's a little flashing light. So it's receiving a signal. Let's see if it's correct. So, okay, there it is. So you see on this chip, it's receiving the signal from that board, outputting to here. And you see this is a hexadecimal values. That's what it should be. So that's good. Right, you'll know that is correct because once I unplug it, it's no longer saying RX bits. There's no bits being sent or received. So I'll plug it back in. Plugged in, and you'll see the amount of bits should be resending. Okay. Might need to close it, but it does say the TX light is lit up, flashing. Anyways, and what happens if you actually plug into the scale, these hex values will actually change. They'll actually increase with more weight on scale. So that's so far how you do it. You got to make sure that first in XCTU it actually shows up correctly, like you actually see receiving data. That's the most important part. Once it goes there, then you can start actually assembling it. So in this case, I'm actually going to put it inside my stainless steel housing. Put the chip from this one into my board, connect it to a scale, and actually start seeing what's going on. So I already put the PCB in the case. See the chip here. Make sure to connect the keypad. So plug that in. Make sure the battery and DC port correct. I did connect the transmit, receive, and ground for the 9-pin, just in case I want to connect to a scoreboard or printer, but anyways. And this one's not here, so I did put a plug here for load cell. And this is just a XB chip. So that's ready, and then on the board, just unplug this. Make sure you plug this in so you could actually able to charge it and use it. Okay, just close this. Close this. And if you remember, we programmed the MicroPython code where it automatically runs once you receive power. So that's what we're hoping for. So I'm actually going to plug this into a scale and close this up and then see if it works. So it's finally finished, but I did have to change the PCB on this one because it was not receiving any power. The 5-volt power for this board was not sending it to this chip. I actually had to switch it to another board and test it out, and it was working. So always make sure you turn it on, and you should see the power light turn on. And once you turn on the module, you'll see the D out on there lit up. So you just make sure your board is always correct. Maybe you soldered the pins wrong. I'm not sure what exactly, but that board was not working, so I switched it out. But to show that it works, error 6, because it doesn't have the module plugged in. So what you actually do is connect it to your platform, and I'll show you how the light turns on, and then we'll see how it calibrates. So first, plug it into your scale, make sure it's turned on, and actually then turn on the indicator. So it's calibrating, it's booting up. It takes a while. Usually it gives error 6, but you're going to go through it. I already calibrated this unit, but you'll see on the chip on the back, the lights, these two turn on, and the D out should be flashing because it's receiving the signal from this board over here. You can see it here. And then you just go through the normal calibration. So C12 is for pounds, C20 because there's 0 decimals for floor scale, 1 pound accurate, 5,000 pound capacity. C51 when I zero out my scale. C06, move it to 1. So 165. So now I'm going to stand on it and press print. Okay, so make sure your weight's stable. Cal end, remove the weight. Press print, and then press accumulate, save, and exit from the menu. And it should go back to 0. It might take some time, and then put your weight on it. In my case, stand on it. That is my correct weight, and you can see how it's wirelessly communicating. My scale's on the bottom, but there's no link between the two. So that's how you set up and calibrate the OP900 wireless.